This is another naming and writing chemical formula review for you, otherwise called chemical nomenclature. So I've already done one video where I gave you the name and I asked you to find the formula. We're just going the opposite way this time because in reality, in chemistry, you've got to have both sets of skills. You've got to be able to bounce back and forth. So this is a lot like the other video. We're just going the other way. As we go through it, I'm going to talk to you about each example. We're going to identify it. Is it just an element? Is it a cation, an anion, diatomic gas, polyatomic ion, ionic compound with a transition metal, which requires the stock method. Is it a covalent compound? Maybe it's a hydrate. So we have a lot of things that we know how to recognize now, so we'll talk about those as we go through. The bottom line is, especially beginning chemistry students, you literally cannot have enough review and practice on this, because the better you are at this, the better you'll be at everything in the chemistry curriculum. So we're just going to get started. I'm going to go through this just like I would sitting in a classroom with my students. Number one, we just have N, just an uppercase letter. That is simply nitrogen, the element nitrogen right off the periodic table. Now number two, we have that N, but we have a -3 charge. Nitrogen is in the -3 column on the periodic table, and nitrogen is a nonmetal. When nitrogen takes on that charge of a -3, that means it has become the anion of nitrogen, so we refer to this as nitride. So this is just an element, and this is an anion. If you're taking notes, I think writing this down is super helpful because it gives you something to look back at later. All right, number three, NO3. A lot of students might look at that and think, oh, that's nitrate. But in order for it to be nitrate, it's going to have a -1 charge. This is simply two nonmetals, which makes a covalent compound. As soon as I identify that as covalent, I know it's okay to use the prefixes. I know that I have to use the prefixes. This is one nitrogen. We do not write mono for the first one. 3 oxygens. So nitrogen trioxide. Number 4 is very similar, except this is nitrogen dioxide, also covalent. So again, because these are covalent compounds, we use the prefixes. And basically what's happening here is your subscript is becoming your prefix. That's a good little way to remember that. Something else I'm going to point out while we're talking about covalents, they always end with IDE. So we could also make a note of that. Just some important little pieces of information for you as you go through this as a review. Now number 5 is the nitrogen symbol with a little 2 to the lower right. That tells me that this is nitrogen gas. Nitrogen gas is a diatomic molecule. Nitrogen can't exist alone in nature. It's always going to be bonded at least to its clone. So there's 7 of these, and you may remember me talking about this in an earlier lesson. Go to 7, draw a 7. I don't have the periodic. Let me see if I can find a copy real quick. Here we go. just a brief little lesson for you on that. If you go to 7 and draw the number 7, right there are 6 of your diatomic molecules. And when you see N2, that's nitrogen gas. O2, oxygen gas. So if you pop a little 2 on the bottom right after each of these, it goes from just fluorine to fluorine gas, chlorine to chlorine gas. And we also add hydrogen to that mix. I always tell my kids, invite hydrogen to the party. Go to 7, draw a 7, easy to remember. So N2 is nitrogen gas. Now, NO3 negative 1 is simply the polyatomic ion nitrate. NO2 negative 1 is nitrite. These are polyatomic ions. I cannot stress enough to you, if you'll just memorize the basic ones, your life will be so much easier. They're just really nice to know. And I'll make a note here, this was a diatomic gas. And we've just memorized those as well. So I put a lot of things together that have some things that you would think would be really similar, but you're also seeing all these subtle differences. That's just very important, and that's why I wanted to group these all in one section. So let's look at number 8. Now the first thing that stands out to me on this is that H in the front. That tells me this is going to be an acid. Now, because it is just hydrogen bonded to a nonmetal, this also tells me this is a binary acid. And when I name a binary acid, I simply write hydro, whatever, in this case chlorine, but I change the ending to ic. So this is hydrochloric acid. We only use hydro in front of binary acids. So for binary, which is hydrogen with a nonmetal, with a negative charge, whatever that happens to be, they're crisscrossed together, we use hydro in front. So we use hydro in the front, and they always end with ic. So just a few little brief notes for you on binary acids. Now, number 9, 2 things catch my attention. This fat dot and the fact that I have some waters hanging onto this molecule. So this is a hydrate. And on top of that, the ionic part of the hydrate also has a transition metal in it. That means I'm going to have to use Roman numerals when I name the ionic part. So when we name a hydrate, we name the ionic part, which is your salt, and then we note how many water molecules are loosely attached to that molecule. So I'm going to deal with the ionic part first. This is copper something nitrate because I see copper and I see nitrate. But what I've got to figure out is what was this charge before it was crisscrossed, because that's going to be my Roman numeral. Now, there's an understood 1 here, which should have come from up here. That makes sense because nitrate overall has a -1 charge. Because this 1 matched to what would have been a -1 up here, then this 2 must have come from up here. So this is copper 2 nitrate. And then we look at this number 4, and we know the prefix for that is tetra followed by hydrate. Copper 2 nitrate tetrahydrate. So not only did we have a hydrate, we also had a transition metal involved in the ionic compound. There are 2 great lessons that can help you with this. There is a lesson on writing and naming ionic compounds with the stock method. that I have posted, and also I have a lesson just on hydrates posted. And I would encourage you, if you were unclear on those, just to go back and look at those lessons. They walk you through step by step. Now, number 10, I2, that is one of my special diatomic gases. That is iodine gas. And also notice we don't change the ending of the element name. When it's a gas, we just say the name of the element and gas. That's it. Number 11 is a covalent compound. Because of that, these little subscripts are just going to turn into my prefixes. This is tricarbon heptoxide. Now, because hepta actually ends with an A and then oxide starts with an O, remember that AOs turn into just O's, so we really just drop the A off of the hepta. It's just good chemistry etiquette. All right, number 12, this is ionic. I know it's ionic because I see a metal. First of all, that's a big clue because you're not going to have any metals in covalence. And then I have the polyatomic ion hydrogen sulfate, HSO4. And I know that has a -1. Makes sense that it's combined with the sodium in a 1-to-1 ratio because what happened is the ones canceled each other out. So we just say what we see, sodium and then hydrogen sulfate. Students will sometimes get a little confused when they see a polyatomic ion that actually is made up of 2 words, but it's just a polyatomic ion. That's what its name is. Again, sodium and then hydrogen sulfate. Number 13. I know that's ionic because it is a metal and a nonmetal. Because it's ionic, these little subscripts play no role in the name. That's the only way that aluminum and oxygen can ever be combined because that was dictated by the original ions that were crisscrossed. I'll show you that in a second. But when it's ionic, you just say the name of the first one, the name of the second one, ending in IDE, unless it's a polyatomic ion like this one. If you have a polyatomic ion, just write its name. If you don't have a polyatomic ion for the second one, change the ending to IDE. So this is aluminum oxide. And I do want to go back and talk about the ions that made this. Because aluminum has a +3 and oxygen has a -2, when they crisscross, Al2O3 is the only way that these guys can ever pair up. So because of that, it's not necessary to talk about the 2 and the 3 when we're naming it. So in ionics, never use prefixes. And this might be a great place to write that. Never use prefixes for ionics. Just a little side note for you if that's been giving you any trouble. And the last one, Ca+2, that is simply calcium ion. If you'll recall from the lesson on ions, specifically the lesson on cations, when a metal loses electrons and becomes a positively charged cation, remember cats have paws, cations are positive, we don't change the ending of the element, we just add the word ion to the end. When a nonmetal steals electrons and becomes a negatively charged anion, that's when we change the ending to IDE, like fluorine becomes fluoride, oxygen becomes oxide. But for positive cations, you don't change the ending, but you do add the word ion. All right, let's look at one more page of examples, and then I feel like you have had a really good review on this, looking at all the different things. Number 15 is ionic. It's ionic because I have a metal and a nonmetal. Zinc is one of the exceptions. It always has a +2 charge. For that reason, we don't use the stock method, even though this is located in the transition metal area of the periodic table. Remember, aluminum, zinc, silver, and mercury are always understood charges, so we don't use stock method for those. So we just say what we see. This is zinc bromide. Say the first, say the second, ending in IDE. Number 16. Now this one is a little bit different. You know, I always tell you that acids start with H, and that's what you should look for. This one is kind of an exception, but there are two ways to write it. This is actually acetic acid. I'd be curious to know how many of you out there already knew that. If you've had lessons on acids and bases, you probably do. It's vinegar, just a very common weak acid. And what happens is the acetate ion is actually CH3 COO -1, and I'm not really sure exactly why, but most people will just pop that hydrogen, that hydronium ion right on the end. So that's just a good one to know because you'll probably see that down the road, and that is one of the ways that it is frequently written, and we'll address the other way later. Number 17, that is ionic. It's a metal with a polyatomic ion. This also happens to be a transition metal, so I'm going to have to use the stock method, like which titanium was it? 1, 2, 3, we're going to have to figure that out. So we know it's titanium something hydroxide. The question is, which titanium was it? And I just tell students, don't overthink this, but just put on your detective cap and ask yourself basically, before this thing was crisscrossed, what was up here? I'm going to guess a 3 because there's a 3 down here that had to have come from up here. In order for that to be correct, this would have had to have had a -1 charge because that's what's down here. And that's true. Hydroxide has a -1. It looks like the 1 came here. For that reason, I can be confident that this 3 came from up here. So this is titanium 3 hydroxide. Let's just say that you're not real confident in your skills. Just write it down and double check it. If titanium was a +3 and hydroxide is a -1, when you crisscross, yes, you get TiOH 3, you can be confident that you were right. That just takes a second. Totally worth your time if you're learning these. Number 18, this one's a little unusual. It is an ionic compound because it has 2 polyatomic ions. Typically with ionic compounds, we're used to seeing a metal first. But because ammonium is a positive polyatomic ion, when it's in an ionic compound, it's going to be written first because the positive ion is always written first. So in this case, you just say what you see. Now, if you don't have your polyatomic ions memorized, then that's going to look like a real beast. I mean, I have seen some very creative ways of naming that when a student doesn't know polyatomic ions because there's a lot going on. However, if you know them, hopefully you quickly say that's ammonium and that's chromate, ammonium chromate, that's it. Again, know those polyatomic ions. Number 19, I know this is ionic. I also notice that I have a transition metal, so I'm going to have to use my stock method, my Roman numerals, to indicate which iron that is. Is it 1, 2, 3, whatever. But let's go ahead and write down what we do know. We know it is iron something, and that is the polyatomic ion sulfite. Now the question is, what was the charge on this iron before the crisscrossing happened? Now I know that sulfite is SO3 - 2. So I would expect a 2 to be down here, but there's not a 2 here, it's a 1. So what that is a clue for me that either some charges canceled out or they were reduced before the crisscrossing happened. So sulfate, this is sulfate, you don't mess with any of that, so you don't mess with that little subscript. But if sulfate's a -2 and it is combined in a 1-to-1 ratio with iron, what must have happened is this iron must have been a +2 because it looks like the 2's canceled. So I think it's iron 2 sulfite, but I am going to check that. So if iron has a +2 and sulfite is SO3 -2, the 2's do cancel, just smack them together, and you do get FeSO3. So again, I know I was correct. Number 20, this is 2 nonmetals, boron and silicon. That is going to be a covalent compound. That means that this 2 and this understood 1 are going to become my prefixes. So I'm going to say diboron monosilicon. We do use mono if there's only one of the second atom that's listed. So diboron monosilicon. Actually, that changes to E. S-I-L-I-D-E. That looks really odd. All right, number 21. I'm going to have to go back and look at that. That looks really strange. Number 21, this is covalent. You have a nonmetal and a nonmetal. We don't use mono with the first one, so this is nitrogen trifluoride. Number 22. I immediately recognize this as a hydrate. This is going to be ionic. This is just a regular group 2 metal, barium, so I'm not going to have to use the stock method. I'm just going to say what it is. So this is barium chloride. By the way, this is a hydrate. Barium chloride. Dihydrate. Okay. Number 23. Now, number 23 is one that I always tell my students, hey, it's really good to know this. It shows up a lot. This is not an organic chemistry class, so a lot of folks may not be familiar with that, but that is methane. And even though this is not organic chemistry, that does tend to show up pretty frequently in my class. We use it a lot when we're talking about combustion reactions. So it is just really good to know that CH4 is methane gas. All right, number 24, AS3I8. That is covalent. These are going to become my prefixes. This is going to be triarsenic octaiodide. And that is a tongue twister for sure. Okay. Number 25. H2 is one of the diatomic gases we have memorized. That is just hydrogen gas. Okay. 26. As soon as I see that charge, I know that is a polyatomic ion, and this is the polyatomic ion hydrogen carbonate. So make a note, that was a polyatomic ion. All right, number 27. This is ionic. I know it's ionic because I have a metal and I have a polyatomic ion. I also know that that metal is a transition metal, and what that means is it's in that transition block at the periodic table, and I'm going to have to use the stock method or my Roman numerals to actually tell you which chromium we are talking about. So I'm going to do a little detective work here. I know it's chromium something dichromate, but which chromium was it? So I know that dichromate has a -2 charge, but there's not a 2 here. So that tells me something was probably reduced or maybe possibly canceled out before the crisscross happened. So I've got to kind of think backwards and try to figure out what that was. This 2 that came from up here, it can't happen because a 1 didn't come from up here. So I'm thinking that might be chromium 4. So over here at the side, I just want to see if I'm right. Chromium plus 4 and dichromate Cr2O7 -2. Now these don't cancel, but they do reduce. If that 2 were to come down here outside the parentheses, that actually matches up with this. So I was right. This is chromium 4 dichromate. In my opinion, this is the trickiest type when we're looking at the stock method with transition metals, because occasionally they will reduce, and that should always happen before they're crisscrossed. Number 28 is lithium. And number 29 is the lithium ion. That is just a cation, so we did not change the ending. And that's it. So that was pretty successful review. Hopefully as you were following along, you're finding out, yeah, I'm getting better and better at that. I am going to go back and check that number 20. Something's not ringing right with me on that. I'm actually looking that up and getting a variety of answers on the internet. So I'm going to do a little more looking into that. I'll be honest, that's one I'm not super familiar with, so I'm going to check it out. You might want to do the same. But overall, we've seen a very good just mix of all the different things that we might be asked to name in beginner's chemistry. So, you know, maybe try those again by yourself. I'll try to get up another mixed review later. Any of these individual ones gave you problems, just go back and look at those videos on YouTube.